Hello, good people of AP Calculus. Let's talk a little bit about the product rule. Curiously, when you have a function that is multiplied by another function, you can't just take the derivative of both of them and call it a day. The product rule goes a little something like this. You take the derivative of the first one, you multiply it by the second, plus the first one multiplied by the derivative of the second. There's some really cool proofs of why this fact is true, but they are quite complicated, and so we are not going to do them today. We're just going to practice with them a little bit. This is your assignment, and I have selected, I think, 5 problems that I'm going to do with you. So first one, you note that we have two things multiplied together. That your first function, your f of x, is x to the 5th, and your second function is e to the 2x. So the derivative function will be equal to something times something plus something times something. Take the derivative of the first, that's power rule. Leave the second alone. Plus, leave the first alone. Take the derivative of the second, that's going to be our exponential rule. E to the power, derivative is e to the power, and then the derivative of 2x is 2. Now, curious thing that happens when you do the product rule, zoom in on this a little bit, is that you end up with 2 terms. Here's your first term and here's your second term, and I would like you to get into the habit of factoring out anything that you can factor out. So in the case of this problem, let's see, I've got a 5 and a 2, no common factors there. X to the 4th and x to the 5th, I could take an x to the 4th out, and I could also factor an e to the 2x out. And if I did that, let's see, here we'd be left with a 5, plus here we would be left with a 2x. So I would like you to write your answers in this form. Okay, so there's our derivative equation. Let's try another one. This one's going to be a little kookier. I'm going to go down to number 7. Okay. Number 7, we see that we have 2 functions multiplied together. So our derivative is going to be something times something plus something times something. I'm going to have to squeeze a little bit to make this one fit. Derivative of the first function. Oh, by the way, I'd like to note that right here, our degree is 4 plus 7 is equal to 11. So when we're all done at the end of the problem, we're going to expect that the degree is going to be equal to 10. Okay, so here we go. Take the derivative of the first one. If you say that's 4 times 2x plus 5 to the 3rd power, and you stop there, you're wrong, because you forgot the chain rule. We have an inside function, and the derivative of that inside function is 2. Times, leave the second function alone, plus, leave the first function alone, multiplied by, take the derivative of the second one. Again, this is going to be a chain rule, so bring the 7 down to the 6th multiplied by 5. All right, now just like on the previous problem, see how we have 2 terms? In my opinion, this is the hard part. You need to factor everything you can out of those 2 terms. So I've got a 4 and a 2, that's 8, and then I've got a 7 and a 5, that's a 35. They don't have any common factors. But I can see that right here, I have 3 factors of 2x plus 5, and here I've got 4 factors, so I can factor out 3 of them. And then right here I have something to the 7th, and here I have to the 6th, so I can factor out 6 of those. And then let's look at what we have left. Because there were two terms, see two terms, 1, 2, we know that here we're going to have two terms as well. First term would be, let's see, we factored out all of these, but we didn't take the 4, right? We didn't take the 2, so it's going to be 8. And then we took all but one of these factors, so we're left with a 5x minus 3. Plus, right here, we took all of these. We didn't take the 7, we didn't take the 5, so that's 35. And then we didn't take one of these factors. We only factored 3 of them out. So there's a 2x plus 5 in here. And now we're almost done. The last step is going to be to clean up what you've got right here. So let's see. This is 40x minus 24 plus 70x plus 535s would be, what is that, 150, 175? Did I do that correctly? We'll go with that. Okay, so that's going to be 40 and 70 is 110 x's, and then 175 take away 24 would be, what, 150, 140, 151. Did I do that correctly? Hang on. Times 4 is going to be 140. Oh, this is, no, okay. All right, we're going to go with that. So this is 2x plus 5 to the third, 5x minus 3 to the sixth, and then 110x plus 151. And I'd like to note that the degree right here is 1. That means that our degree is going to end up being 3 plus 6 plus 1, which is 10, which is exactly what we predicted. Woohoo! So there is your answer. Now we're going to continue by taking a look at number 6. Number 6, you can see that you got two things multiplied together again. So when I take the derivative by the product rule, we're going to get something times something plus something times something. And I wanted to go over this one because of what happens when you take the derivative of the square root of x, also known as, I'll rewrite this, x to the half power. So the derivative of that is half of x to the negative half times, leave the second one alone, plus x to the half times the derivative of the second one is 2. Right here, we take the x to the negative half, we move it to the denominator. So you're going to get 2x plus 5 is divided by 2. Now this 2 right here is from the 1/2. Right, that 1/2 is 1 in the numerator, which multiplies this and doesn't change the value. And then 2 in the denominator, x to the positive half power. Plus, over here we have 2x to the half. So that's your derivative. I would like you to take one more step, and that's this. I would like you to get a common denominator. And the way you're going to get a common denominator is you're going to multiply this by a very creative 1. And the 1 you're going to multiply this by is 2x to the half. So that same denominator here and here. Now let's see what that does. That gives us a denominator of 2x to the half. And then here we're going to get, let's see, 2x plus 5 plus right here, that would be 2 times 2 is 4. And x to the half multiplied by x to the half, let me emphasize this, I'm going to write this off to the side. X to the half times x to the half is x to the half plus half, which is just x, which is lovely. because it means that now we can combine the 2x and the 4x, and we're going to get 6x plus 5 divided by the quantity 2x to the half. And there's our derivative. All right, I'm going to flip to the back side. Let's take a look at number 9. This one's asking us to find the second derivative of this expression. And it's important to notice when you don't have the product rule. So this is not product rule. And the reason it's not product rule is you don't have two functions multiplied together. You have one function which has an inside and an outside. So step 1, if we wanted to take the derivative, we would just use my buddy, the chain rule. So 3 links in the chain. Derivative of cosine is negative sine of leave it alone, multiplied by derivative of e to the something is e to the something, multiplied by derivative of 6x is 6. So the first derivative is negative 6. Actually, let me delete that. I want you guys to put the e to the 6x first, sine of e to the 6x. Okay, second derivative. Now we have two functions, right? Now we have something times something else. So now it's going to be a product rule, which means we're going to get something times something plus something times something. Here we go. First function is this. Negative 6 e to the 6x, derivative of 6x is 6. Multiplied by, leave the second function alone. Plus, leave the first function alone. The derivative of this would be cosine e to the 6x, 6. Okay. So we got a big old mess here. And we want to clean this up. We could factor something out if we wanted to. I don't think I'm going to this time. I think instead I'm just going to say this is negative 36 e to the 6x sine of e to the 6x. And then right here, e to the 6x times e to the 6x is e to the 6x plus 6x, right? When you're multiplying on bottom, you are adding the exponents. So that would be e to the 12x. So this would be minus 36 e to the 12x cosine of e to the 6x. There we go. One last problem for today. I'm going to zoom out for this. Let's take a look at number 12. Number 12, you're given the f function and the g function. And I'm just going to do a. A says to find the derivative of Hector at 3 if Hector is equal to Franny multiplied by Georgine. So the first thing you're going to do is say that by the product rule, the rate of change of Hector is Franny prime times Georgine plus Franny times Georgine prime. So first thing you're going to do is recognize that this is product rule. And then you're going to plug in a 3. And then let's evaluate. Here's 3 on Franny. So it goes through the point 3, 4. That tells us that of the 1, 2, 3, 4 spaces we need to fill in, this one's going to be a 4. And the slope right here is up 2 over 3. So Franny prime of 3 is going to be 2/3. And then let's go to Georgine. Here's 3, bump, bump. Georgine passes through 3, comma 7. So this is going to be a 7. Our slope at this instant is down 1, 2, 3 over 1, 2, 3. So our slope is equal to -1. So this would be a -1, which means our answer is going to be 14/3 minus 4. Get a common denominator. So that's 14 minus 12 is 2. So 2/3 is going to be our answer. All right. The rest of the problem set is yours to complete.